Hi, Nikhil. Am I audible?
Yes, ma'am.
Oh, okay. Uh, Good. I thought I will wait for some more people, but this will be recorded, so we'll start the class. And hello, I'm Basumati. I'm your course instructor. There will be another instructor whose name is Mr. Chakravarti Jada. He will also be taking live sessions for you. So the course structure will be we have 12-week content where each and every week has two different types of assignments. One is non-graded practice assignment, another one is graded assignment. I think you will be aware of it because the first week has been released, I think. So you are supposed to submit the assignments before the deadline, and for your final evaluation, all the assignments scores will be considered, and the weightage was also proposed in the websites. Each and every week has one live session that is scheduled on Wednesday 5 to 6 p.m. So we will be taking classes during that time. That time you can join the live session and ask your doubts. We will solve some problems from our side, and if you have any doubts in any particular problems in assignments or something else from the book, we will address that also. So I hope this live session will be an interactive one. We both can discuss about the things and we learn together. Right. For the first week, I will try to give some introduction and we will solve some problems based on that. And if you have any doubts or if you have any queries, please stop me in between and ask your doubts. Unmute yourself because I'm moving away from the meet recording. I won't be able to see your chats. And there will be surprise quizzes in between the live sessions. That marks will also be added to your grading.
Ma'am, is the quiz and interim are CBT based or pen paper based?
Oh, like quiz will also be taken for the weightage. Some 15 to 20% that will be decided. Two quizzes will be there.
No, ma'am. I'm asking, is our quizzes are CBT like subjective or objective?
Oh, objective it
CBT
will
based
be.
or pen paper?
Objective computer based.
Okay, ma'am.
You may expect MCQs, MSQs, short answers like fill in the blanks.
Yeah,
There won't be
understand.
any short answers to type or something. Uh, like more than 2 words. Okay.
Okay, madam.
All right. We will start with week one. So week one most probably have introduction to the control systems that doesn't have any serious topic but lay the basics for the thing you are going to study in the upcoming weeks. First of all, people are from different backgrounds, so I want to give a general introduction for the control systems. In control systems, we interchangeably use different terms like systems, signals, feedback, and loops, gains, etc. So, in control system, any system can be considered to be a control system. For example, if you can give an input to a system and you expect some output to the system, so this we call if you give input to some black box and get an output out of it, then you can call that as a system. And signals are any variables are called as signals that changes with respect to time. So that we call it as signals. So usually the system takes a signal as an input and give out an output as a performance or spec, whatever we call. For example, if I consider a fan as a system, I'll be giving 234 by 235 volt as an input, and instead I'm getting speed according to my criteria as an output. For example, if it is a fixed speed, I would call it as 200 RPM. So this system takes input signal as voltage as a signal and gives out speed as a performance or an output based on the nature of the system. Where the control will come inside this. is what we are going to learn. So if I have a fan at my home, I must have a regulator for it, right? The regulators can be specified into 1, 0, 1, 2, 3, 4, up to 5 maybe I will take. So what this defines is, if you choose this 0 to be your regulator criteria, then you are telling that the fan should be off. If you are choosing 5 as your regulation criteria, then you are mentioning your fan should be running at a high speed, maximum speed it can run. That's the on criteria. So in general, we call this as a binary, where it is either off or on. So we generally use this 0 for off and 1 for on in binary terms. So in between, if we insert this analog terms 1, 2, 3, 4. So these are all the terms corresponding to the speed into some numerical alpha. So if the alpha is equal to 1, you would expect the maximum speed, that is on. According to your binary, it is 1. So when alpha is 0, it is off. So in between alpha ranges, that we call it as this analog variations, what we expect. How can we say, if I keep my regulator in 2, or if I keep my regulator in 5, for example, if it is EC, my maximum speed is 200. I would expect 200 RPM. I am keeping my regulator in 5 position, and the fan is giving some output in RPM. How can I say that it is exactly giving the maximum RPM? How do you know that in real time? We can see the visible difference between the changes in speed, but we cannot claim that it is running at very high RPM. That is 200 exactly numerically or mathematically proven, right? So that's where comes the sensor part. So this sensor helps us identify whether the system is running at the high speed or the defined speed, whatever speed we want. So first we learn there is a system and we are giving a signal as an input, and I am getting some output that is also a signal in terms of performance or specifications. And now I am introducing another term called sensors here. So this sensors will tell whether the output I am expecting is the output it is giving, both are same or not. Expected output is equal to the true or original output. Whether these are same, this will be monitored, or this will be identified using the sensors. So if I want to put this together, how can we put it? I am giving an input and a system, and I have a sensor here, right? So now these are independent system. I'm putting this sensor, I'm connecting the sensor either externally or internally using a wire or some connection devices like USB cable, and sense the parameters in the systems. Now, if I want to, I have two scenarios. One is I'm giving 230 volt output and I'm expecting 200 RPM as a, I'm giving 230 volt input to my fan and I'm expecting 200 RPM as an output. Now I have a sensor. This sensor is sensing, it is giving only 190 RPM. Now, whether these are equal? No, there is a difference between this output that is giving out of the fan, the fan is giving, and the output I am expecting. The difference between these is 10 RPM. So how can I compensate for this 10 RPM? This is the next questions. So I can regulate the system or change my regulator little bit so that I can achieve the expected output. This is another criteria. But who will be the point of contact? Those who be sitting there and changing the regulator then and there when it exceeds or it minimizes. So it's very cost expensive, right? Putting a person over there. So we are designing a system that can do this work by itself. We are closing the loop by doing this. It's my input and my output. So my input is 230 volt, my output is 190 RPM for now. My sensor is sensing this and telling the system that you are not giving an expected output as 200, you are giving only 190. So I am sending this as an feedback. So that we call it as feedback loop here. So this will be sent to the system. So the system will identify the difference between the expected 200 versus the 190. Based on this difference, it understands that there is a 10 RPM difference between the expected versus the actual. So the system will regulate itself by changing the input to 230 to 232 volt so that it can achieve this 10 RPM. For example, after changing 232, I am getting 195 RPM. Again, the sensor will give this as a feedback 195. Then it will sense there is a difference between this as a 5 RPM. It will change this to 232 to 235, let's take. Now I have achieved a 200 RPM. The sensor now won't go back from its loop. It will just sense the 200 RPM in an infinite loop. When it changes from 200 to 210 or 220, it will try to reduce the input voltage. So this is considered to be a entire functional closed loop system. Right. Now we learned what is the actual system and the closed loop system. This actual system I put in before, that we can also call this as open loop system, because there is no feedback to close the system, right? So if there is a feedback, there is a sensor in the feedback, and if we connect these 2 points together using a sensor, we call it as closed loop. Otherwise, this is a open loop system. Now we'll learn what is the basic difference between the open loop and the closed loop. So the open loop has only the feed forward path, as we discussed now, out input and output. And the closed loop system has a extra parameter, that is a sensor or a feedback I used to call, and this will be given back to the system. So this is the basic difference between these two, how it is being operated. Now in the open loop, the input will be independent of the output. Input will be independent of the output, but the output depends on the input, as in any system, right? So the input is independent of output. But in closed loop system, input can be manipulated based on the output or the performance or specifications, whatever term you want to call it, right? So this open loop system, I'm going to call this as OL system, that is open loop system. These are inherently robust to noise. This is one good thing that you expect in open loop system, but again, this is for a simple system. I don't expect closed loop system in fan. On the other hand, I will expect closed loop system for an AC. This is a basic difference between where we can use open loop and where we can use closed loop. When the resource is too much and I don't want to make it complex, I will leave it to the open loop system when the system doesn't experience any external noise or any disturbance. But closed loop system, if I want a particular or a perfect control, or my control accuracy, excuse me, is very important, then I will go with the closed loop system with the trade off of using more resources when compared to the open loop system. These are basic examples for this, right? And what else? Then there are in the first week content, you would have seen the properties of the system. We will brief little bit about the properties. So far, do you have any doubt?
No, ma'am.
Okay. Fine. So the properties can be defined into, why do we study properties of any system? Why do we need to know?
For finding better sensor for like uh, better communication between sensor and systems for doing better communication.
Exactly. Very, very good. And to know the nature of the system and to know better about the system so that we can do a better control, right? So that's why we want to know the properties of any system. If we know this, we will be able to control it better. So there are some basic defined properties of a system. First one is linearity, which is more popular. If you know whether the system is linear or non-linear, I can choose a control which is linear or non-linear to apply for that particular system. Then that is static versus dynamic, causal, non-causal, time variant, invariant. What else? Periodic, aperiodic, which are well defined, but still we have this different types of classification. Apart from this, we have broader classifications like continuous time system and discrete time systems. Also we have time domain operations, in which domain we are going to operate. So those can be split into, those are different classification. Those can be split into time domain operations or frequency domain operation. I'll brief each and everything. Excuse me. So we will start from the linearity. Linearity defines system that follows superposition principle. What superposition says? It has two intermediate step: homogeneity, additivity. This tells when I give an input 1 to a system is common and I'm getting a output 1. If I give another input, I'm getting another set of output. And if I add input 1 plus input 2, it should be equal to adding the output 1 and output 2. So this is the basic understanding of the linearity. If this doesn't work, or this the system doesn't follow this property, then we call that system as a nonlinear system. If the system doesn't follow the superposition principle, we call that system as a nonlinear system. For example, uh, y equal to mx, let's take mx plus c. I am taking two types of system, y equal to mx and y equal to mx plus c, right? Now I'm considering x1 as input 1, x2 as input 2. When I give x1, I'm getting an output y1. When I give x2, I'm getting output 2. This is for system 2. For system 1, when I give x1, I'm getting y1. Similar, x2, I'm getting y2. Now, when I add these two systems together and these two separately, y1 plus y2 will give me mx1 plus mx2. This adding together, y1 plus y2 will give me mx1 plus c plus mx2 plus c. Okay. So this will give me y1 plus y2 equal to simply m into x1 plus x2. Here the same thing will become m into x1 plus x2 plus 2c. So you can see the difference here. Now when I replace all the x with only um, x1 and x2 with x, I will get the same thing here, right? If I write as a original system, for y I have y1 plus y2, for x I have x1 plus x2. But if I write the same system here, I will get y for y1 plus y2, x for x1 plus x2. But instead of c, I have 2c here. So this is the issue here. So it has created an extra parameters which is not there in the original system. Hence, this system is non-linear. It doesn't satisfy the superposition property. While this system satisfies the superposition property, so this system becomes linear system. So not all the line equation will be linear. You can see that this is y equal to mx, while this may be y equal to mx plus c when the intercept is 2, let's take. So both are seems to be linear, but this doesn't cross to the origin. So superposition property has this exclusive thing where the system will always go through the origin. Excuse me. So that's how you differentiate between linearity or linear systems. That's how you identify whether the system is linear or not. Whatever system you will be given with, you will try to do this test. X1 plus x2 should be equal to x1 plus x2. Like this is replacing x is equal to x plus x1 plus x2. This is replacing x equal to x1, x equal to x2, and then adding it together. So both should give the same results. If yes, it is linear, otherwise it's not. Then comes causality. Causality tells whether your system need a future input or not, or your system depends on the future input or not. A system is causal causality. It is right. When the system is causal, if it doesn't depend on future input. Right. There are two different things here to focus on. One is doesn't depend on future input. That is the next thing. Okay. It doesn't say what it depends on. It is just saying it doesn't depend on future. Rest of the things will be included, it seems. So a causal system, if this is present, this is past, this is future. Causal systems will have this kind of things. Okay, it is glitching a little. I don't know why this is happening. Okay, it has all the parts that doesn't have the future. That's what I'm trying to tell. Okay. Right. There is another. So, for example, if the system x of t or y of t equal to x of t plus x of t minus 2, there is no future. When t equal to 0, this will be minus 2. When t equal to 1, this will be minus 1. T equal to 2, this will be 0. So whenever it is 0, this will be the past of it. So it depends on only the past. For example, if I give you a system t minus 2 plus x of t plus 2. Then when this becomes t equal to 0, here it will be minus 2, here it will be plus 2. So here, when when compared to the present, this depends on the future along with the past. That doesn't matter. If future comes into the picture, then the system automatically becomes a non-causal system. Okay. Future, if it has any single, even at least a single future term, then it becomes non-causal. Okay. Wait, let me close and open it again. That's non-causal. Similar to, there will be another classification where people used to get confused with this. The third term is static versus dynamic. So you see the last term, if the future involves, it is non-causal. But if it depends on past and present, it is causal. But here, only present it should be dependent on. If it is present, it is static. If it has past or future, both, then this become dynamic system. It should not have any memory. The other name for this is memory or memoryless system. So the memoryless is, that it depends only on the present. If it depends on past or future, it will automatically become a memory, also called as dynamic. It is not static, it is dynamic. So this can also be represented in terms of past, present, future. Then the static system depends only on the present input. Again, this is very important, input. It's not telling about the output or any other histories. If it depends on the present input, then the system is static. Otherwise, it is dynamic. Similarly, here this is causal. This would be. So please don't get confused between these two types. If it depends only on present, it is static. Otherwise, dynamic. A dynamic system could be causal when it depends on past. A dynamic system will be non-causal when it depends on future. So this could be the like true or false question or any choose the best answer question. All the dynamic systems are causal. All the dynamic systems are non-causal. Some of them are causal, kind of. If it depends on past, then it is true. Otherwise, it is not. So please try to learn the difference between the static, dynamic versus causal and non-causal systems.
Ma'am, any example like how a system depend on future, like
Okay, for example, I can give you an example for dynamic. Mm, For example, it's like a predicting a system, how the next signal would be. At the next instant of time, if I'm giving a step input, for example, a step input will be at 0th timestamps, it will become 1 if it is a unity step input. It will become 1 and the rest of the times it will be 1, right? If I know the input is step, I can say that any instant of time this is going to be 1. So I can also predict the future will be 1. For example, stock market pricings. People are predicting the gold prices like tomorrow how it will be, but it won't be never same. But people are predicting that and taking that as an input for today's to analyze whether it is safe to invest or not, right? So this kind of systems are dynamic systems or non-causal systems.
oh, okay, ma'am, understood.
The next classification is time variance or invariance, that it's very straightforward, right? So if the system, if I give a input at timestamp t equal to 0, and it is giving an output. When I give the same input, the keyword is important. When I give the same input at next timestamp, and if it gives the same output at the next timestamp also, then the system is time invariant. It will vary only with respect to the input changes, not with respect to time. Right? Any instant of time, if I give the same input, if the system gives the same output for all instants of time, then the system is time invariant. Otherwise, the system is variant. If I give step input, I'm getting a ramp and I'm getting a parabolic here, then the system is time variant, non-invariant. If I give the ramp again, then the system is time invariant, right? I hope that is clear. I didn't confuse it there. And periodic nor aperiodic systems are it will give out the same output after every defined period of time. For example, if it repeats every t seconds or t time steps, minutes, t minutes or any time. So x of t plus t, capital T, will be x of t. For every t seconds, the input will be same as the one that happened before the t second. Right. Um, I hope I have concluded all the contents in week one. If you have any doubt in practice assignments or graded assignment, you can ask, or any general doubt about the course, anything, please feel free to ask.
Ma'am, is there any G space for this course?
It is generally it will be. I think they are yet to create one. Maybe they have created and not added the students. I will. I will check with it. Okay, it will be
Okay, ma'am.
created soon.
Ma'am, please send this recording link for
Yes,
notes.
yes, it will be updated. It will be updated.
Okay,
There will
ma'am.
be a sheet link given in the course page. There you can go and check.
Okay, ma'am.
But in general, if I take 1 hour session, the recordings will be there after 15 or 20 minutes. So I will take that evening to upload. Sometimes I will get busy, but within that day, I'll try to upload the link.
Okay, ma'am. Okay.
Right. Thank you so much. If you don't have any doubts, we can conclude the session. I'll be here until 5:50. If you have any doubts, you can ask.
No, ma'am, not any doubt.
Okay. Thank you then.
Thank you, ma'am.